In this video series, we're going to look at the topic of research designs and the general linear model. Those two ideas, the idea of design and modeling, come hand in hand. The design helps us know how to create the study in order to obtain observations, and the general linear model is how we actually analyze the responses that we obtain after we conduct the study using our design. So design and analysis are two different aspects, but both are very important and required for our studies. I teach a course on experimental design and analysis, so we talk about how to design studies and then how to analyze the data obtained from those studies. The general linear model provides a common framework for analyzing response variables. And indeed, that is the essence of science. Why do we observe what we observe? What is causing those observations? In behavioral, social, and medical sciences, why is it that individuals are providing for us those observations? Why are they responding the way they do? Why are the medical characteristics the way they are? And determining what are the influences or what are the causal effects to create those particular responses is the essence of the studies that we do in behavioral, social, and medical research. We want to make a connection to establish cause and effect. Let's talk first about research design. A research design is a blueprint for how participants will be exposed to the conditions of the study. First thing is that we have factors and covariates of the study. I'm referencing factors the way that we have been referencing factors when we use R as categorical variables and covariates as quantitative variables. Now be careful with that terminology because some people use the term covariates to mean that you're statistically controlling a variable, and I'm using it more generally here so that the covariate could be an explanatory variable as well as a statistical control variable. So anytime we're putting the explanatory variable as a quantitative variable, I'm referencing that as a covariate. When you're using factors or covariates, they can be experimental or they can be observational. Let's take a look at a study that I analyzed in a past video series. This is the one in which we looked at women who were receiving Rogaine or placebo as a way to affect baldness and to be able to increase hair growth. So in this particular example, and I'm focusing on this line graph here because it helps us see the individual characteristics of the study, we have a condition which is treatment or control, and we randomly assign to that condition. Therefore, that is an experimental factor. Experimental because I randomly assigned, factor because it's two categories. Now, the weak number could be treated as either a quantitative explanatory variable, that is a covariate as an explanatory variable, or because all quantitative variables could be used as factors if we choose, and indeed when I did this analysis, that is how I chose to do it, this could be a factor. So one has to determine, are we using these quantitative data as quantitative data or are we putting them into categories? And I put them into categories. So we could have had either a factor or a covariate here, but I used it as a factor. In either case, regardless of whether we considered it a factor or a covariate, we did not control the weeks. Yes, we controlled which weeks we measured, but we did not control the weeks themselves. All of the women were measured at all of these week numbers here that you see, 0, 8, 16, 24, and 32. So because I was not putting these week numbers as an experimental condition, and I don't know how I would put them as a condition unless I was going to say observe some people randomly chosen for 1 week and some randomly chosen for another, but that's not what we did here. We measured everyone on these weeks. So this is an observational variable. And in this case, again, it could be an observational covariate or an observational factor. We treated it as an observational factor. So when you have factors and covariates in the study, they can be experimental or they can be observational. We can have multiple experimental factors. We can have multiple observational. We can have only experimental factors. We can have only observational. Really, there is no limit to how we treat this. In this particular course, I'm restricting the number of factors and covariates that we're looking at in the study. But if you were to take, for example, my experimental design course, we go beyond the numbers of factors and covariates we do here, and you should be able to see that there's no limit to how many experimental factors or observational factors you put in, and each of those would correspond to a new research design. Because one of the aspects of a research design is the factors and covariates in your study. In addition to that, we're also concerned about extraneous variable control. Remember that to ascertain cause and effect, you need temporal precedence, you need covariation of your explanatory and responses, and you need to account for alternative explanations. And that's where extraneous variable control comes in. There's a literal experimental control that can be achieved two ways, either by matching, and remember that if you use the same participant multiple times in multiple conditions, that is really an extreme form of matching. Not only are you matching an individual with an individual like that individual, you're doing the ultimate match. You're using that individual as their own match. And that would be a repeated measures when you're looking at someone under different conditions. Or we could have random assignment as a method of extraneous variable control. And that is to remove the systematic bias of extraneous variables because we randomly choose which condition someone's going to be in. If we're going to match, it's a good idea to include both matching and random assignment. That is to match individuals in a block fashion and then randomize, and the design for that would be called the randomized block, where we not only match individuals, but choose who's going to get what treatment condition. So random assignment and matching are two ways to achieve experimental variable control. Now, another way that we could do it is through statistical adjustment, but note that that's not actually a researchers controlling influence. That's rather observing what we're observing in terms of our potential extraneous variables and then trying to adjust for that, the way we did when we went through the series on analysis of covariance. So statistical adjustment is a way of adjusting for an extraneous variable, but it's not necessarily removing systematic bias. And I talked about that in that ANCOVA series, that if we in fact have an extraneous variable that is in some way related to our response variable, we can actually obtain results that are not corresponding to reality and could in fact be the opposite of reality. So that has to be done with great care. But nonetheless, the reason we do statistical adjustment is to account for extraneous variables. It's just in that case, we have to put the word control here in quotes. Going back to this Rogaine study, we actually used experimental controls of randomization for the condition, the treatment and control group. And we use the experimental control of quote-unquote matching, that is, we use the same individual as their own match by taking repeated measures. So we used both types of experimental control in this example. And then there are the ways that you decide to measure your variables, whether those be categories or whether they be quantitative variables or covariates. Now, you can have categories both for your explanatory side, that is your factors, or for the response side. In the videos that we have done in this course, we've never seen categorical on the response side. However, we're going to see that before the course ends. And when that happens, it's actually no longer called a general linear model. It's called a, get this, generalized linear model. Not very good thinking in terms of naming these things because it can lead to much confusion. We're focusing on the general linear model because that is what we've done up to this point in the course. That is, on the response side, we've always had a covariate, that is a quantitative response measure. But we've also had covariates on the explanatory side, variables in which we're using continuous data or quantitative data in order to be able to predict what we get as a response outcome. In fact, the earlier videos in this series, when we first learned about multiple linear regression, we have quantitative data both on the explanatory side of the equation and on the response side of the equation. Looking back at my Rogaine example, I'm using the amount of hair that is growing in each of these time periods, looking at how much hair we have for each of these women by taking a little snippet of hair from, I believe it was a square centimeter or something like that. And so we're actually weighing that amount of hair. So we're using a quantitative response measure here, whereas we treated both the condition and the weeks as categorical factors on the explanatory side. So for the general linear model, you can have categorical factors or quantitative covariates on the explanatory side, but you only have quantitative response measures if you turn it into a categorical response measure, that is categories, these response categories, then that would be considered a generalized model. So that is the research design. We've actually gone through several designs. We've looked at the one-factor randomized design. That's a common design. We analyze the data with the multiple linear regression as we do with everything with the general linear model. However, that's often called one-factor analysis of variance. Now notice that I can quickly switch from the word randomized, take that out of there, and just say a one-factor design. Because if we have categories that we did not randomize, we would still analyze the data the same way, but what would be influenced is the way we interpret our outcomes. We could no longer interpret the outcomes as cause-effect outcomes because we no longer have an experiment if the various categories that we're assigning people to, or sorry, not the word assigning, that was a non-purposeful slip that helps make the point, that we're not assigning to, that is, we're just observing, and then you would take out the word randomized and call this a one-factor design. Similarly, if we have two factors, then you can have two randomized factors or any combination of randomized and observational factors. You could have one randomized factor and one observational factor. In a previous video, I did a study of guinea pigs, or I didn't do the study, but I used the data from that study. And in that case, guinea pigs were assigned both to a dosage and to a method of delivery of vitamin C. And because they were randomized on both of those, we would call that the two-factor completely randomized design. If we only randomize on one of the factors, we would just call it a two-factor randomized design, with randomization, of course, being on that one factor and the other one being observational. Or if we took out the word randomized completely, it would be a two-factor design in which you're simply observing. The researcher is not controlling the explanatory variables, but just observing pre-existing variables. In a randomized block design, we match individuals and then randomize to conditions. You can guess what we would call it if we matched individuals and did not randomize. We would just call it a block design, or maybe to make it even more explicit, a block design without randomization. You notice here that these terms that I'm using are not fixed in stone. These are not fixed so that, oh, we better memorize these. Rather, what you're doing is you're describing how you're actually designing your study. And so I don't care if you call, for instance, the two-factor design as a two-factor design with randomization on one factor and observation on the other. That would be a great name. It's not a name we have to memorize. It's just a name in which we're describing the level of experimental control that we have over each of the factors. So in a block design, if I say block design with no randomization, or maybe someone else calls it an observational block design, same thing, right? And without the word randomization, we know that we do not use this removal of systematic bias through randomizing to conditions. A repeated measures design, we're measuring the individual at each of the different treatment levels, or even more commonly, using time as the factor and looking what happens over time. And then you could have a mixed design in which you mix having a factor that is a between subjects factor, which you could randomize on, and then you could have repeated measures for the other factors, so you could see what happens in two different groups. Now think of all the possibilities in that mixed design. I just called it a mixed design here, but we really could be more explicit upon what we did. We could say that we had one randomized factor and then repeated measures on the other factor. That would be a fine way to describe that design. Or we could have an observational factor and then repeated measures on the other factor. So any factor like that, or anything like that in which we take and have correlated measures versus uncorrelated, like when we assign to conditions or take observations of individuals that are independent of one another in independent groups, that would be a mixed design. A randomized design with a covariate would mean that we randomize on a factor, but then we're also measuring a covariate in addition. You could also have an observational design with a covariate. And in fact, when I looked at analysis of covariance in a previous video, that's what we had. We did not have randomization to the different ethnic groups. We took existing groups, but then we had a covariate that we were looking at, their years of education, to see if that maybe had an influence on income levels. So remember, we're talking about research designs in the general linear model. I focused in this video on research designs. In the next video, we'll start talking about the general linear model.